Hello everyone, we have just over a minute before we would normally start, so I'm just going to wait here for the last minute people to join in, and it's 3 o'clock we will start the presentation. Thank you. Thank you everyone. Okay. Before we begin, I need to point out that as usual all participants are on mute for a better experience so you can hear me. This webinar is being recorded, and at some point we'll have a version of it on the website should you wish to refer to it later on. Please use the question panel on the right hand side to ask any questions as we go along. Handouts are also available and the handout panels on the right hand side. Webinar feedback survey will be sent out at the end. Please complete this should you require a certificate, either for continuing professional development uses or for your employers. Please register for future webinars at blatchford.co.uk/webinars. And if you have any questions about this or future webinars or anything that comes up during this course, please email me at john.ross@blatchford.co.uk. So today's webinar will be on the latest version of the KX06 version 2, with a history on hydraulics. The presentation will be presented by myself. I'm John Ross, Principal Prosthetist and Commercial Manager of Blatchford's. I've been prosthetist for 27 years. I still practice prosthetics here in South East London, and I have also spoken and taught prosthetics around the world. I have a keen interest in the holistic approach to prosthetics, and especially in transfemoral prosthetics, both in the sockets and the shape and how it interacts with the patient, and then the effect the alignment of components have on top of this. So today's agenda, I will start with what's new and what's not with the KX06, give some background to the development, some of the engineering and science behind this, the fitting recommendations, and some common questions before the summary at the end. So what's new? The latest version of the KX06 is waterproof again to the current standards. So the standards are constantly changing in prosthetics about what is and what isn't water resistant, what is waterproof. This now meets the latest standards. Previously on the KX06, we had used an engineering standard for mechanical joints. However, when we presented this to the ISO standard committee, it was not accepted. So hence we had to retest it to the latest standards. The latest version of the KX06 is slimmer. than the previous version. And you can see on the diagram closest to the text there, you can see how we've chamfered and actually changed the shape of the struts on it. We have a shorter design. We've managed to save 10 millimeters in build height, which will make it easier for us to fit into smaller people. We've added a cover to reduce the risk of finger trap, especially as the patient sits down and bends the knee fully, so there's less chance of any children or anything getting caught in there. A latch or a clip has been added to the back of the knee. This is to prevent self-adjustment. And we have new bearings throughout to protect the cylinder. As a result of requests from clinicians in the field, we have incorporated the T-slot attachment at the top, so you can fit in a range of different adapters to make it as easy as possible to get the alignment. We've also kept the 4-bolt attachment at the top, so this is similar to the Orion and Mercury knee. So we have a unique waterproof knee, still consisting of the dual technology from the previous KX06. In this, we have a coupling of hydraulic stance and swing with polycentric geometry. These work together to provide outstanding stability in all terrains, yielding for stairs, so the patient can walk down steps leg over leg, and also it has 2 user modes incorporated in the knee. So same as many microprocessor legs in the world, we can walk down steps leg over leg, and we have those user modes where the patient can go into cycling or fixed lock. This is a robust knee. Okay, it's intended for K3 or K4 users, and it comes with a weight limit of 150 kilograms. The 4-bar polycentric design is inherently stable and less prone to accidental release. So as the patient lands on the heel, with this unit, they will either get stability from the geometry of the polycentric or stability from the hydraulic cylinder, which works in partnership with this. The hydraulic cylinder is a long hydraulic cylinder designed for smooth experience with the ability to yield down steps leg over leg. So we have either stability coming from the geometry of the polycentric nature of the knee or from that long hydraulic cylinder. As I've already mentioned, we have 2 user modes controlled with a stirrup at the back of the knee. So we have a flexion lock. This will allow you to switch on, and then the knee will resist any flexion. However, it will allow the patient to ride up into extension. And we also have the cycling mode available for the patient. The knee is really aimed at those people who have work or leisure involving lifting, moving objects, and for active walkers, and people who are involved in sports, hiking, camping, and tough mudders. Those people who are doing assault courses through various different climates and terrains, submerging the leg underwater, going through mud, etc., etc. Contraindications would be residual muscular weakness, as intended for the K3, K4 active user. Proprioceptive dysfunction, you need to be able to tell when the leg's in the air and when it's on the ground and what it's doing, so the patient always tenses muscles at the right time. Contralateral joint instabilities or pathology could also be a contraindication. Depending on the severity of these instabilities, the patient may be better off with a microprocessor control, where you can actually affect the stability more. And it's definitely not intended for K1 users. So moving on to the background of technology. As I said before, the KX06 is a combination of polycentric geometry and long hydraulic cylinder. The hydraulic cylinder we use is an S&S type knee. An S&S is a generic name used around the world for a design of cylinder pioneered by German engineers Hans Mauch and Ulrich Henschke. These cylinders were developed with the support of the American Veterans Administration. And in 1968, the modern hydraulic Henchmark S&S knee was developed. These cylinders can be produced under license for free in the United States of America, and we still use this in our Mercury knee. Okay. And what happened was that the engineers decided to couple the benefits of this long hydraulic cylinder in the Mercury knee with the polycentric geometry, and I'll come back to this in a minute. First of all, looking at how the long cylinder works. In stance phase, at heel strike, the weight line passes behind the knee. This encourages the knee to flex or buckle, creating instability. However, at this point, the hydraulic stance is on inside the hydraulic cylinder, and this gives you the stability. Inside the cylinder, the counterweight and pendulum is in the down position. This switches the stance phase or stance valve on. Okay, so it's in a closed position, and what you're doing is you're actually driving that hydraulic fluid through a valve that is controlling how the knee responds to the patient's required for stability. Moving on through mid stance, we now end up with a neutral position. The knee is stable due to body weight and momentum. So the ground reaction vector is passing in front of the knee. This helps keep the knee stable. However, at this point, the stance valve is still on. That counterweight and pendulum are still down, holding the stance valve closed and therefore controlling the movement of oil or the hydraulic fluid. In late stance, to toe off, the knee is hyperextended. Okay. At this point, the weight line is passing sufficiently far in front of the knee that the piston in the long hydraulic cylinder is pulled up. This raises the counterweight and the pendulum and opens the stance valve, therefore allowing free flow of the hydraulic fluid. However, even at this stage, the knee is still stable. At this point, the ground reaction vector is keeping the knee stable, and this allows some natural pre-flexion, in that the knee will slowly begin to flex even before the foot is totally off the ground. In swing phase, the leg swings forward. There is no longer the pull trying to open the hydraulic cylinder, so the stance valve is turned back on. The stance is activated during knee extension, and this also helps provide a stumble recovery feature for users. Okay. As the leg is swinging forward, the stance valve switches closed, so it switches on, stance is back on, and it means that we have that stumble recovery feature. So come back to the KX06. It was a unique combination of polycentric knee and the benefits of the hydraulic S&S swing and stance, providing optimal stability. One of the big benefits of using the polycentric was the ease of initiation of swing. It was found that the polycentric had less effort than a swing axis knee, single axis knee, and I'll come back to this later on. Polycentric geometry allows for an increased toe clearance during swing, okay? Just as the way that the polycentric actually changes the center of rotation, allows for some shortening of the leg during swing phase. The geometric stability provides greater security on all terrain. There was less chance of the patient coming down, hitting their heel too hard into the floor, and therefore switching the stance unit off and creating an unstable mode. Should the patient do that, because they have driven the heel into the ground, the geometric stability from the polycentric unit will keep them stable and secure. As I said before, the hydraulic control provides a smooth walking, allowing both yielding for coming down stairs and steep ramps, and a variable cadence swing control due to the nature of the hydraulics itself, so the patient can change speed and the unit will keep up with them. One other advantage this is the large flexion angle of 160 degrees, which allows the user a greater degree of flexibility where they need to be sitting on the floor or getting in and out of car, or just getting the foot out the way when they're sitting down. We have a new robust design, designed to withstand more demanding activities and environments. Okay, no matter what you do, should a patient go in a tough mudder, do an assault course, contaminate the leg with mud, all they need to do is simply rinse the knee with fresh water. As I said before, the unit is intended for patient weights up to 150 kilograms. The unit is now waterproof. Okay. However, it's important to state that the knee must be in the locked position. Okay, so using the stance lock and fully extended when submerging underwater. We have reduced the maintenance. The new bearings mean that you no longer have to service the cylinders. So we should only ever have to do anything should something go wrong. The integral cover, which is now supplied as part of the knee, provides protection from the environment and also prevents the trapping of fingers, which had been on and off a problem. The unit is 10 millimeters shorter. So even though these extra benefits of the improved bearings, the waterproof, and changing the top to accommodate the requirements of many clinicians, we've also managed to reduce the overall build height. And in doing that, we've still maintained one of the major benefits of the KX06, that when the patient sits down, the knee will only extend 30 millimeters from the end of the socket. And part of the design to make it more robust, we have used these self-aligning bearings arrangement at both ends. These isolate the cylinder from bending and side loads, okay, to give it a longer life and a more consistent function. Over the years that we've noticed from the previous version of the KX06, these unusual side loads are actually one of the most common reasons for damaging the unit and was the most common reason for actually requiring it to be serviced. We've also incorporated a latch or a clip. This ensures the swing extension resistance setting are secure. So there's no chance of your patient kneeling on the ground and moving along ground and then rotating the settings in the cylinder, okay? Or from the cylinder adjusting itself because it's hit against something, or any of these reasons. There's now a physical latch which closes down and then locks it off. This again will be a benefit to the users because it means that the unit is more robust and means that they don't have to adjust the setting again, no matter what they're doing. And as I said, the unit is now back to being waterproof, okay, though it should be locked when submerged. As part of the extensive testing that's completed on this new version of KX06, what we looked for was the most active users. And in test machines, so a combination of these has shown us how much we've improved the function of this unit. One of the reasons for doing a test machine is that there's no rest periods. Amputees will have to stop and rest at some point. But however, on a machine, you can just keep on applying the maximum pressures and loads and keep it going all day and all night continuously. Okay? So we have checked what happens when you apply a toe load, or either as a normal phasing for an amputee, or if a machine just does it constantly. We have looked at the swing testing as well as immersing the unit in water and making sure it's still functioning. One thing that allowed us to do this was the sealing of the bearings. Okay, these bearings are now sealed to ensure dust does not penetrate to the cylinder or to the rotating pivots, and they reduce side loads, so they actually protect the cylinder from whatever the amputee is doing. Well, one of the things we also wanted to keep was a familiar design. Many amputees have been more than happy to wear a KX06 since its launch in 2007, and the most recent version was in 2011, and many amputees still have a good experience of this. So by keeping the familiar design and the functions the same as before, from the amputee side, then it makes it easy to upgrade a patient onto this new version. The unit still allows fine tuning for the swing phase, extension and stance resistance, either by the clinician or by the patient. There's easy selection of modes for cycling and standing support. Again, these are well liked by the users of this type of unit, and we have kept a simple way of switching these on and off so that there's nothing new for the amputee to learn. By the addition of the T-slot and the above, we've now built the shift adapters, and this gives us the ability to shift the socket anteriorly and posteriorly in relationship to the knee, using our range of T-slot adapters. And we're really there for the clinicians, because it means once you've made the socket, if you need to do a small alteration, you can still do that. So you have the ability to shift the socket slightly further forward or slightly further back without having to remake the socket. And in doing this, we've still managed to say keep to that 3 centimeters from the end of the socket to the knee when it's fully bent. And I'll talk about some of the science behind this and the evidence for using this type of knee. This knee was initially started life as a design concept as part of a European grant looking to provide a mechanical knee that would give the benefits of a microprocessor knee to knee disarticulation patients or long transfemorals. Okay. And the combination of 4-bar mechanism with a stance and swing hydraulic cylinder provided geometric stability combined with the ability to yield, so it gave those functions. However, this latest design has been to improve the durability of the existing features and also allow submersion in water. When we look at polycentric knees, we look at the instantaneous center of rotation. And at any given time, the instantaneous center of rotation is at the intersection of the joint centers, each links. That's this change. So we draw a line up through the center of the joints, and where it crosses, this is the instantaneous center of rotation. And what we see is that this changes as the knee flexes, and this is what gives us our shortening of the limb during swing phase, reducing the chance of catching the toe and therefore falling. At heel strike, the instantaneous center of rotation is actually above the top surface of the prosthesis. Okay, so as we carry those lines up, they cross over there. And this makes it inherently stable. That's why I say that when we use a geometric stability from polycentric, we actually end up with a more stable position than we get from the uniaxial knee using the exact same hydraulic cylinder. So with the instantaneous center of rotation being higher, it means that there's less effort for the amputee to stabilize. Okay? And the more posterior position that you get from this combination means that the unit is geometrically more stable and your weight line is likely to pass in front of it, helping keep the unit stable on the patient. And then what we see is stance phase progresses, the ground reaction force vector will pass behind the instantaneous center of rotation, and at this point swing phase can be initiated anytime, even when the leg is extended. So this makes it easier to initiate, as there's no longer geometric stability once a ground reaction vector passes behind the instantaneous center of rotation, and actually allows what we call pre-flexion, and that the knee will begin to bend while the foot's still in contact with the ground, even if the patient still has some weight on it. As I say, the instantaneous center of rotation is a key point to giving the stability of this leg. Even though we were making the unit shorter, it was key that we kept that instantaneous center of rotation the same, so that when our users who had wore a KX06 transferred onto the new version, they didn't notice a difference. So we spent time making sure that the tracking of the instantaneous center of rotation is unchanged with the previous version of the KX06. Okay. This again makes it easier for older patients on a KX06 to transfer the new one, but also means that other patients who have not worn this type of knee will get this benefit and notice the increased stability. During flexion of the knee, when it's swinging in the air, the instantaneous center of rotation changes, as you can see with the transference of the red dots here. So as the knee flexes, the center of rotation moves away from the patient. Okay, so it moves more distal to the patient and then starts to actually track through the metal joint itself. And as the knee extends, that instantaneous center of rotation moves back up into the socket. One of the things we also notice, because of the tracking and the way that a polycentric knee moves, that the swing resistance is lower for the first 18 degrees compared to a single axis knee. Okay. This helps improve the clearance in early swings, so reducing the chance of catching the toe for small degrees of movement. And this is due to the piston traveling less than initial flexion. So when a polycentric knee flexes, to get the same angulation movement, you don't have to apply so much pressure down through the piston. Inside the hydraulic cylinder, there's a large spring, which is an extension bias. Because you don't have to compress that extension bias as much, it means that you get earlier heel and toe rise. The next thing to look at is the lever arm. So the Mercury knee is our hydraulic knee using the exact same cylinder, but in a traditional uniaxial knee. So the lever length in this case is perpendicular distance from the cylinder axis to the knee center. So if we draw a line up from the center of the cylinder, and then we draw a line parallel with this that goes through the knee center, this will give us a distance, which is the lever arm. When we do the same again, we take a line up going along the line of the cylinder, and then we draw a line parallel with this we then draw a line that shows us the instantaneous center rotation. So we have a line coming up from the posterior axis and the anterior axis, and where the two of these cross, this is the center rotation. And now we compare that measurement, the lever length, we see it's actually longer. So this means there's less work involved to actually get the knee to release. And when we look at this and combine them, we see as the knee flexion increases, the lever arm or leverage changes more dramatically for the KX06 when compared to a single axis knee like the Mercury. The bigger the lever, the less effort is involved to get movement. Okay, so we see actually we're saving energy for the amputee. But there's more. The lever arm is not the whole story. Piston movement is different from the KX polycentric geometry and the single axis geometry. Single axis moves the piston more for any given angle. So that piston is compressed more to get you a flexion of the knee on a single axis knee than it does on a KX06. Okay. And they both have the same extension bias spring inside the cylinder that you have to overcome. Okay, so that means that you have to compress that spring more on a uniaxial knee than you would on a polycentric knee. And so when we combine these, when we consider the effect of the larger lever arm and how much the piston moves using a single axis as a reference, the result is the KX will flex the knee more readily up to approximately 18 degrees, beyond which it becomes less efficient. So the knee accelerates more readily within the single axis knee beyond approximately 18 degrees. The effect of this is that the KX06 ground clearance is enhanced as the knee flexes more readily than a single axis knee through early swing phase. This is going to give you less chance of tripping or catching the foot, and therefore require less effort from the amputee. Moving on to the product information. As mentioned already, the knee is specifically designed for activity level 3-4 amputees, K3, K4. A maximum user weight of 150 kilograms for the K3 amputee and 140 kilograms to the K4. We've reduced the build height to 220 millimeters. The weight remains the same at 1.34 kilograms. We still have the same knee flexion of 160 degrees, and it comes with a 36-month warranty. Inside the box, you get the knee, you get the cosmetic cover. This is actually sent, not attached, because you're going to need to be able to get into adjust the cylinder. It comes with the spacers required and the screws to hold this cover on so you can put it back in place. A 2.5 millimeter hex or Allen key will be inside the box for attachment screws, and the instructions for use and the user guide are also included. Please note, I know I'm always saying this, the user guide is intended to go to the patient. Okay, it gives them instructions on what to do and what to look out for. We have a much wider range of socket adapters now. Okay, so the numbers 1 to 3 here, there's pyramid male and female, and the 4-bolt, as previously had been able to be used with the previous version of the KX06, but we now have the T-slot adapters that are popular with many of our other knees, which can now be used on this version of the KX06. So it means that you can actually reduce the weight and the build height. The other thing we have is a hydraulic knee control adjuster. This is a peg key that fits over the cylinder and makes it easier to adjust the cylinder by giving you a longer lever length, so you can apply more pressure to rotate the adjustment point. Warranty, the unit comes with 36-month warranty period. Loaners are now available for this product, okay, because they now need to be returned for repair. You can no longer repair them locally or service them locally. You need to send everything back to us. So the KX06 is non-field serviceable. Okay, you cannot take the cylinder out and put in a service cylinder as you could previously with the old version of the KX06. So there's no service exchange cylinder for this design. It should also be noted that the cylinder is slightly different. So cylinders from the original KX06 are not interchangeable with this new version. All this is part of the new bearings we put in to improve the resistance to side loading and to make sure we can get the unit through the latest standards for waterproofing. Moving on to the fitting. As usual, evaluate how the patient is walking on their current prosthesis. Make sure that this type of knee is what they want. Okay, it's an active, rugged knee for active patients. If you just get someone who's wanting to wander about the house and is looking for a lightweight, simple system, this is not for them. All the bench alignment. The starting guidelines are inside the instructions for use in the clinician's manual inside the knee. So make sure you follow the bench alignment before you even take the unit to the patient. Put the prosthesis on and perform your static alignment as you usually would inside the parallel bars. Check the height of the prosthesis. Check the anterior prosthetic static alignment and make sure that the patient is stable and isn't falling over before they start walking, exactly as you would normally. Then carry on through your dynamic alignment, observe their gait, make any corrections, and then adjust the cylinder. So the first stage that is slightly different is fitting the T-slot adapter. Take your cosmetic cover off. You need to remove the knee pad. That's the same as the previous version. Remove the 2 retaining hex screws. They just make sure that your T-slot doesn't fall out in use. Fit it in place and then tighten up the retaining bolts again. Put your knee pad back on. Just to protect the patient. And then that's you ready for fitting. So the alignment, as you can see my patient here, bisect the socket at the ischial level. Fully accommodate any flexion that's involved. So you can see in this case, we have the red line. This is the plumb line that's coming down through the midpoint of the socket at the ischial level. And you can see that actually the midline of the socket is slightly tilted from this. This is to accommodate the flexion in this user. Align through to 5 millimeters posterior to the top anterior pivot position. Okay, so you want to make sure that you got the load line passing the correct position. Align the foot in accordance with the manufacturer's recommendations. So in this case, you can see my user, he wears an Echelon VT. So we use the Blatchford's hydraulic ankle wedge. Then we push the foot into maximum plant flexion, and then we set up the foot. Another key thing is to make sure that at maximum flexion, when you get up to that 160 degrees of knee flexion, that the socket does not contact the cylinder. Okay, it's really important that you don't actually hit the socket on the cylinder on your piston rod. So make sure that the socket is not hitting the piston or the linkages, but is actually hitting the back of the body. Finally, ensure the unit is in stance active, okay, or normal function mode. So at that point, the stirrup posteriorly should be down. So the patient standing on a knee, it should be geometric stability. Okay, so the patient should feel that they're stable there. The yield, okay, or the stance resistance should be present when they push forward. If in doubt, increase the yield to a high level so it can definitely be felt at present, so the patient can actually feel secure, that they can feel a resistance there, because that will be what supports them. As if you take the resistance to the maximum point, there's still no resistance for the patient, then the socket must be aligned too stable. You get the socket way too far forward in relationship to the knee, and this is meaning that even in standing, they're making a hyperextension moment about the knee, which results in a pull on the hydraulic piston, switching the unit into swing resistance. Okay, so if your patient stands there and they get no feeling of yield as they begin to push forward into that cylinder, it means you've got the load line way too far forward. That socket's too far forward. Customizing the yield, what we do is we have the patient sit into a chair, and then we adjust the stance accordingly. Too high a yield and the wearer will slow excessively, pushing them backwards into the rear of the chair. Okay, so you see the patient come down slowly and then collapse into the back of the chair. To a lower yield, and what you see is the user, the wearer, will rely on their sound limb excessively. You'll notice the body aligns and is pushed over the sound limb to make it easier to lower themselves down, and this will cause long-term wear in the joint and the sound limb. Okay, so just make sure you don't have it too low. And I'm going to quickly show you a video showing this. So we adjust the resistance until the patient can feel that they have enough resistance to lower them sitting down. Okay. So if they can feel that resistance, controlling their descent from standing to sitting, it will be enough resistance for them for walking. That once more. So next is to confirm the alignment. Walk patients in the rails initially just to make sure you confirm the alignment. Adjust that as required. Observe the swing characteristics. Adjust the flexion resistance first. So make sure you have the heel rise matching before you do anything else. Okay. If when your patient walks, they don't get the knee releasing into swing phase, it means that you have the socket too far back. And you've got to remember, you need a hyperextension moment over the knee. Okay, so if you're not getting the knee beginning to flex as the patient takes a step forward, it means you've got the socket too far back. Before you can adjust the cylinder, you need to release the cap lock. Okay, this latch at the back of the cylinder is new, and you need to pull it up, okay, to switch it off so you can adjust the knee. So we'll observe the heel rise, pull the catch up, adjust the flexion resistance, so increase it so we control it, push it back down, and then get the patient to walk. Okay. As long as that latch is in the down position, it's locked, always adjust the flexion first. Okay, always adjust the flexion first. Next, we do the same with the extension resistance. So now we release. Observe how the leg is swinging forward. Does it come through fast enough for them? Release the latch, adjust. Take a note of the flexion resistance, adjust it till it catches on the extension, move the extension to the desired position, and then take the flexion back to whatever number you had noted before. Switch the latch back on again and keep on doing this till you're happy. Typically, I find that the extension resistance should be lower than the flexion. Stair descent training is the same as before. So get the patient to yield off the bottom step, then 2 steps, and then 3 steps. Okay. Once you can do all 3 steps, it's the same, repeating the whole thing. So go back over it. First, bottom step, just yielding down the step, making sure the resistance is enough to allow the patient to lower themselves to the ground. Second step, they lower themselves onto their sound foot and then swing the artificial leg forward to make sure they clear the step. And just keep practicing this until the patient feels confident. When you go into 3 steps, you're lowering yourself down, making sure the artificial foot clears and then lands in the correct position for walking on. As I said before, we have user modes in this knee. Normal function or active mode, the stirrup should be down. Okay, so the latch at the back of the knee should be in a down position. That's in the top diagram. Below this, the latch can then be moved into the up position, and that will change it onto the different modes. For cycling, you need to lift the stirrup while the knee is hyperextended. So normally I explain to the patient, push the leg behind them, push down onto the toe, flick the latch or stirrup up, and because the knee is in hyperextension, it will go into a cycling mode. Alternatively, for the flexion lock mode, get the knee in whatever position you want it in flexion. Flip the stirrup up. Okay, so because you've got the knee slightly bent already, there's no hyperextension, and then the unit will let you move forward into full extension, but will not allow you to increase your. It will allow you to move forward into full extension, but not allow you to take any more flexion. Okay, so we can see in that video there's a range of different functions that the amputee can use. They can have it in fixed flexion mode, they can use it for cycling, through wet water, etc. The knee is intended for the most active user. Once you've finished the alignment, it's important that you fit the cover. Okay, so we wrap the cover around it, put on the washer, spacer, and then using a 2.5mm Allen key, tighten the screws in position. This here is really just to protect the cylinder when the patient is kneeling and crawling along the floor, and also to reduce the chance of trapping the fingers inside the unit. Key points to remember: pulling back in the socket or hyperextending the knee will release the knee. Okay, so try and encourage the patient when they land on the heel not to pull back suddenly against the back of the socket. From our experience, it's better to tense or push forward, so pushing forward through the heel for heel contact so that you're engaging the yield. And when compared to single axis hydraulic, initiation of swing is easier because of that increased lever length. Moving on to questions, here we go. Can users run? Yes, amputees can run the KX06. They may desire flipping the mode selection switch to a free swing, especially your fastest runners if they're wanting to sprint. And just be careful that that stirrup doesn't flip back down while running. And saying that, I know many patients who jog or play soccer, football, who just leave the stirrup in down position. It will slow them a fraction of a second over a 60-meter run, but it means that if they have to change direction, etc., or suddenly stop, they have greater control. So it really depends on the level of running and the type of sport you're doing, whether or not you actually put it into the cycling or free swing mode, or you use the normal mode. Is this version more durable? I've had hydraulic failures in the past version. Yes, one of the reasons for designing this unit was because we wanted to increase the durability, which is why we've had to move to these new bearings which remove the side load. So by removing the side load, we've greatly increased the durability of the unit, but on the negative side of this, you can no longer service it locally. We do have a loaner program in place though, so if anything ever goes wrong, request a loaner form and we'll send it to you, and you send your unit back till we find out what's going wrong. The unit does offer a stumble recovery. So as long as the knee started to extend during swing phase, stumble recovery will be on, and so you will have a stumble recovery if the knee is interrupted before full extension of the knee. We have had very little demand for the swing-only version of the KX06. From even around the world. So there is currently no version of the new KX06 with a swing-only cylinder, and there won't be for the foreseeable future. So unfortunately, no, there's no swing-only version. Also, at the same time, the old KX06 is no longer available for order. So we have moved entirely to the KX06 V2. However, should you have a patient who still has the old version, we still have cylinders and spare parts, etc., that can still be ordered for the old version of the KX06. We're not forcing you to immediately transfer the patient over. If the patient's happy with their leg and you just need to maintain it, all the pieces you could order previously for maintenance are still available for the old version. And yes, this is one of the big changes again. The KX06 is again waterproof. It can be submerged in water as long as you lock the knee. And this is as a request of many users, and we have made changes to get it to the latest standards in prosthetics so that it passes this. almost finished. Here we go, we're on to the summary. So the KX06 is the only polycentric knee that allows yielding in stance. This yielding permits step over center stairs. Okay. You can ride this yield down steep slopes and will give you supported sitting. So when the patient sits down, they can keep their weight spread evenly between the two legs so that actually you do less damage to the knee joint on the sound limb. It has a stumble recovery mode. The stance mode comes on as the leg swings forward. And as you can see here, with our user, the unit is now waterproof. You can take it and splash it in the river, play whatever you want to. Okay. The important thing, if you go submerge it in water, make sure you've locked the knee. And also, whenever you have submerged it in this type of thing or taken it in out of the river, make sure you clean it down with some fresh water. So what's new? We're now waterproof. Okay. We have a sleek, robust design with protective cover to reduce the chance of catching your fingers. We've added a latch that prevents self-adjustment of the cylinder, even should the patient be crawling along the floor. We've strengthened the bearings, and we've also brought in self-aligning bearings. These protect the cylinder from side loads. We have reduced the build height by 10 millimeters so that you can fit more patients with it or use longer feet, taller feet. As a direct result of requests from clinicians, we have built approximate T-slot attachments in it, which make it easier for us to get the alignment correct and adjust it to suit individuals. However, there is only a swing and stance version available now. Function, from the patient's point of view, is pretty much the same as before. They walk the same, they have to do everything the same. The only thing is now that unit is waterproof. Okay, and there's less chance of adjusting the cylinder when you kneel or doing something. Can't go over often enough, this is unique. The KX06 is a unique waterproof dual technology knee providing outstanding stability in all terrain. Okay. It's a robust design and we made it even robuster. It's intended for your most active users, those people who are going to be out doing crazy things, climbing over walls, jumping up and down, getting in the river, all those type of things. The more active your patient, the more your patient deserves this type of knee. And we've kept the same ease of use. It's a very simple knee to become used to, and the function of it is very simple for patients to pick up, as well as having those user modes, which are great for these active patients. I'd like to point out our offerings as further information about this knee and anything else we've covered in our recent range of seminars, webinars can actually be found on our website. Also on the website, you will find a clinical compendium. This has taken a series of independently verified scientific papers, and what we've done is just taken each one down to a one page with the key points from the research and the finding. It just saves you having to read hundreds of pages of research when you can just read a summary of the key researchers. We've also have a growing number of white papers. These white papers are intended more for the users themselves, but also for funding bodies, whether it be insurance or hospitals or whatever, showing the benefits of using our devices in a simplified text so that you don't have to be an engineer to follow it. Okay. We just point out again what's happening in the clinical compendium, but we've just removed some of the engineering terms from it in text just to make it easier for people to keep up with. Finally, I'd like to thank you for your time. My name is John Ross. Should you need to contact me, my email is john.ross@blatchford.co.uk. And I should also point out that we have more resources for professionals on blatchford.co.uk/prosthetics/professionals. This is information for all us clinicians out there to help us with our decision making and making sure that we get the maximum benefits from our amputees. So with that, thank you for your time. Please complete the feedback, especially if you need a certificate, and also sign up for any other webinars and have a look at them. They can all be found in our resource section. Thank you.